The Sun is a star that's the center of our solar system, made of hydrogen and helium, and is the largest object in the solar system. Why should we know about Sun? The Sun is the primary source of energy for life on Earth, providing light, heat, and vitamin D. In a simple way, if we are cooking, then we are turn on the gas. The gas is burning and proving heat energy to cook the food exactly same way Sun is a source of energy which providing light, heat and vitamin D. Other facts so we know about the Sun are: solar system. The Sun is the center of our solar system, and its gravity keeps the planets, asteroids, comets, and other objects in orbit. Weather and climate. The Sun drives weather, ocean currents, and the hydrological cycle. Let's start our journey. When did Sun born? The Sun formed around 4.6 billion years ago in the Milky Way galaxy. It's difficult to say who discovered the Sun because humans have been aware of it for tens of thousands of years. However, Nicolaus Copernicus is credited with establishing the heliocentric theory, which places the Sun at the center of the solar system. Copernicus's theory was that the Sun is at rest near the center of the universe, and the Earth revolves around the Sun annually. Size and distance. Our Sun is a medium-sized star with a radius of about 700,000 kilometers. It would take more than 330,000 Earths to match the mass of the Sun, and it would take 1.3 million Earths to fill the Sun's volume. The distance between the Earth and the Sun, often referred to as 1 astronomical unit, O, is a fundamental constant in astronomy. This distance is crucial for calculating various astronomical measurements and understanding the scale of the solar system and beyond. The mean distance between the Earth and the Sun is approximately 150 million kilometers, defining the astronomical unit, O. Various methods have been deployed to measure the distance between Earth and Sun, but modern methods have high accuracy compared to other methods. Surface. The Sun doesn't have a solid surface like Earth and the other rocky planets and moons. The part of the Sun commonly called its surface is the photosphere. The word photosphere means light sphere, which is apt because this is the layer that emits the most visible light. It's what we see from Earth with our eyes. Although we call it the surface, the photosphere is actually the first layer of the solar atmosphere. It's about 250 miles thick, with temperatures reaching about 10,000 degrees Fahrenheit, 5,500 degrees Celsius. It's still hot enough to make carbon, like diamonds and graphite, not just melt, but boil. Structure and fusion of Sun. Mainly we divide the Sun in the below part for your better understanding. Core, radiative zone, tachocline zone, convective zone, photosphere, chromosphere, corona, solar wind, flare, prominence. Core. The Sun's core is the central region of the Sun where nuclear fusion occurs, producing energy that powers the Sun's heat and light. The core is at the center of the Sun, extending about a quarter of the way to the surface. The core is the hottest part of the Sun, with temperatures reaching 15 million degrees Celsius. The core is the only place in our solar system where nuclear fusion can occur naturally. In the core, hydrogen atoms fuse into helium atoms, releasing large amounts of energy. Energy from the core is transferred outward through the Sun's layers, eventually reaching the surface as visible light. Some of this energy reaches Earth's surface and sustains life. Radiative zone. The radiative zone of the Sun is the layer between the core and convection zone that transfers energy from the core to the convection zone through radiation. The radiative zone extends from the outer edge of the core to the base of the convection zone, which is about 25% to 70% of the distance from the center of the Sun to the surface. The radiative zone is made up of ionized hydrogen and helium atoms, which is sometimes called plasma. The radiative zone is responsible for the Sun's flares and CMEs. The radiative zone is very dense, with a density that drops from about 20 grams per cc at the bottom to about 0.2 grams per cc at the top. The temperature drops from about 7 million degrees Celsius at the bottom to about 2 million degrees Celsius at the top. The radiative zone transports energy through radiation, which is the movement of energy in the form of electromagnetic radiation as photons. Tachocline zone. The tachocline is a thin transition layer in the Sun that separates the convection zone from the radiative zone. The tachocline is a belt of heat transition where the radiative interior of the Sun rotates like a solid ball, while the convection zone rotates differently. The convection zone is the unstable outer heat layer of a star. The tachocline is where the rotation rate changes from differential in the convection zone to uniform in the radiative zone. Convective zone. The convection zone of the Sun is a layer in the Sun's interior where energy is transported by convection currents in the plasma to outward. Energy is transported to the photosphere. Heated plasma rises, cooled plasma sinks. Photosphere. The photosphere is the visible surface of the Sun, which is the first layer of the Sun's atmosphere. The photosphere is what we see when we look at the Sun in visible light. We can see sunspots, solar flares, granules, and convection cells in the photosphere. The photosphere is a thin layer of plasma that surrounds the Sun and radiates the light we see. It's about 100 kilometers thick, which is very thin compared to the Sun's 700,000 kilometer radius. The temperature of the photosphere is between 4,500 and 6,000 Kelvin. Chromosphere. The chromosphere is a thin layer of plasma that appears red due to the hydrogen in the Sun. The word chromosphere comes from the Greek root chroma, which means color. The chromosphere is usually not visible to the naked eye, but can be seen during a solar eclipse or with special telescopes on satellites. During a solar eclipse, the chromosphere appears as a thin, brightly colored ring. The chromosphere's temperature ranges from 4,000 K near the surface to 8,000 K at the top. The chromosphere is characterized by dynamic phenomena such as filaments, prominences, bright points, and spicules. Atmosphere. The photosphere, chromosphere, and corona are all part of the Sun's atmosphere. The Sun's atmosphere is where we see features such as sunspots, coronal holes, and solar flares. Orbit and rotation. The Sun is located in the Milky Way galaxy in a spiral arm called the Orion Spur that extends outward from the Sagittarius arm. The Sun orbits the center of the Milky Way, bringing with it the planets, asteroids, comets, and other objects in our solar system. Our solar system is moving with an average velocity of 450,000 miles per hour, 720,000 kilometers per hour. But even at this speed, it takes about 230 million years for the Sun to make one complete trip around the Milky Way. The Sun rotates on its axis as it revolves around the galaxy. Its spin has a tilt of 7.25 degrees with respect to the plane of the planet's orbits. Since the Sun is not solid, different parts rotate at different rates. At the equator, the Sun spins around once about every 25 Earth days, but at its poles, the Sun rotates once on its axis every 36 Earth days. Moons. As a star, the Sun doesn't have any moons, but the planets and their moons orbit the Sun. Rings. The Sun would have been surrounded by a disk of gas and dust early in its history when the solar system was first forming, about 4.6 billion years ago. Some of that dust is still around today, in several dust rings that circle the Sun. They trace the orbits of planets, whose gravity tugs dust into place around the Sun. Magnetosphere of the Sun. The Sun's magnetic field is generated by the flow of electrically charged particles inside the Sun. The field has two poles, like a bar magnet, and its shape and complexity change over an 11-year cycle. The magnetosphere's shape is similar to a comet, with the Earth near the head and the tail trailing away from the Sun. The vast bubble of space dominated by the Sun's magnetic field is called the heliosphere. Since the Sun rotates, the magnetic field spins out into a large rotating spiral, known as the Parker spiral. Approximately every 11 years, the Sun's geographic poles change their magnetic polarity, that is, the north and south magnetic poles swap. During this cycle, the Sun's photosphere, chromosphere, and corona change from quiet and calm to violently active. Solar activity can release huge amounts of energy and particles, some of which impact us here on Earth. Much like weather on Earth, conditions in space, known as space weather, are always changing with the Sun's activity. Space weather can interfere with satellites, GPS, and radio communications. It also can cripple power grids, and corrode pipelines that carry oil. Impact of the Sun on the life of Earth. The Sun's impact on Earth is far-reaching, affecting life, the climate in many ways. Life. The Sun's energy is the foundation of life on Earth. It provides the heat that allows liquid water to exist, which is essential for life. Sunlight also powers plant growth, which provides food and oxygen for animals and humans. Climate. The sun's energy drives the weather by warming the air in the atmosphere. The sun's brightness also changes slightly over time, which can impact global temperatures. Environment. The sun's energy powers the hydrological cycle, which moves water around the planet. The sun also influences ocean currents and wind systems. Human evolution. The sun played a key role in the Neolithic Revolution, when humans transitioned from nomadic hunter-gatherers to agricultural settlements. Renewable energy. People can harness the sun's energy to generate electricity through solar panels. Solar power is the third largest source of renewable energy in the world. Health. The sun's ultraviolet, UV, light can harm living things, including humans. Excessive exposure to the sun can increase the risk of sunburn, premature aging, and skin cancer. How many artificial missions have sent to study the sun? Many artificial missions have been sent to study the sun, including Parker's Solar Probe, launched by NASA in August 2018. This spacecraft was the first to fly through the sun's upper atmosphere, the corona, in December 2021. Solar Orbiter, launched in February 2020 by NASA and the European Space Agency, ESA, this mission studies how the sun creates and controls the space environment. Advanced Composition Explorer, launched by NASA in August 1997. Solar Terrestrial Relations Observatory, launched by NASA in October 2006. Solar Dynamics Observatory, launched by NASA in February 2010. Solar Dynamics Observatory, launched by NASA in February 2010. Interface Region Imaging Spectrograph, launched by NASA in June 2013. Solar and Heliospheric Observatory, SOHO, launched in December 1995 by NASA, ESA, and JAXA, Japan Aerospace Exploration Agency. Hinotori, Astro A, launched in 1981 by Japan's Space Agency, JAXA. Hinode, Solar B, launched in 2006 by Japan in collaboration with the US and the UK. Aditya L1, India's sun mission that aims to improve our understanding of the sun's dynamic behavior and forecast space weather. Quick facts. Length of day, 25 Earth days at the equator and 36 Earth days at the poles. Length of year. The sun doesn't have a year, per se. But the sun orbits the center of the Milky Way about every 230 million Earth years, bringing the planets, asteroids, comets, and other objects with it. Star type. G2b, yellow dwarf main sequence star. Surface temperature. Photosphere 10,000 degrees Fahrenheit, 5,500 degrees Celsius. Corona, solar atmosphere temperature, up to 3.5 million degrees Fahrenheit, 2 million degrees Celsius. Thanks for watching the video. If you have any suggestions, kindly write below on the comments. You're most welcome if you have any suggestion for improvement.